Hello all. Today we are going to talk about friction. Now, it's a very important branch of mechanics. Mechanics, when I say, then we remind of ourselves of Newton's laws of motion, right? Same way, the study of friction is known as tribology. Okay, the study of friction uh, because friction is present in all the machinery, all machine parts, right? Because of that, it plays a very significant role. Like when we make tires or when we make machine parts, how friction is going to appear or how we can reduce it, right? That comes under this study. So study of friction is called tribology. Okay, now what is friction? When I ask you, uh, this definition should come to your mind, that friction opposes the relative motion between the bodies in contact. So this word is very important, relative. So in the simplest sense, if we say that there is a surface A, right, and there is a body B, which is moving, which is made to move in this direction, right? So friction due to A will oppose the motion of B. So in what direction it will act? You all will agree it will act parallel to the surface, right? So friction due to A on B will act in this direction. Okay. Now let us take a second example. Suppose there is a, let us say there is a wheel and car wheels, you know that its velocity is in this direction also, this is called rolling motion. Now again, this is B and this is A, right? Two bodies in contact. Now if you pay attention to the bottom part, you will find that this point wants to go in this direction. So friction due to A, let us say again this is A and this is B, friction due to A will oppose it. So this body B will feel a friction in this direction. Now same thing happens when we try to walk. So we try to push somehow the ground in backward direction. So we try to push the ground in this direction, right? Somehow. So if there is no friction, you will not be able to walk. So what happens? The ground pushes you in this direction to oppose your relative motion. Now, if you want to climb a tree or a rope, let us say, so what happens? Suppose one monkey or one person is thinking to climb tree, so you will find that the person will, if there is no friction, he can't climb, right? So what happens? The friction will oppose. So this person will push the tree, or this monkey will push the tree in this direction on the surface. So what will happen? The friction will oppose its motion. So if you see, just like walking, okay, so if the monkey will push the surface in this direction, so on the feet of the monkey or on the hand, the friction will be in this direction. So friction opposes relative motion, okay, not the motion. Now coming back, uh, if a body is at rest and no pulling force is acting on it, then the force of friction is zero. So if a block is lying here, let us say, and no force is acting, there will be no friction here. Okay, now you know that if a block is at rest, then this will be normal force R, let us say, by the ground, and there will be a mg force due to earth. So it is very easy to understand that why there will be no friction force, because if you say friction is in this direction or this direction, then it will start moving, right, which will violate the conservation of energy principle, or right. So if there is no pulling force acting, then friction is zero. Fine. Now coming back, we have three things depending on what do you say, surface are at rest. So if surface are at rest, surface are in sliding motion or relative motion, or surface are in rolling. So if the surface are at rest, then static friction operates, and we are going to denote it, static friction, by F subscript S. And we are going to denote kinetic friction Fk, and we are going to denote rolling friction by Fr sim. Now, when the surface is at rest, so let us take an example, what we mentioned here. Suppose this is at rest, fine, and you started applying force on it. And let us say when you apply force, then also the block is not moving. So if the block is not moving, it is easy to think that somehow this surface is at rest, so it will apply a force of friction in this direction to cancel the applied force. So this surface is at rest, so the friction which will operate here is called static friction. Now suppose as you apply the force, the block starts sliding, right, in this direction. Now the surface of the block is in relative motion. Now the friction which will act will be called kinetic friction. Okay. Now rolling friction, as we mentioned, suppose when something rolls, fine. We are going to talk about this later in rotational mechanics. So in this case, rolling friction will appear when a body will try to roll. Fine. Now, uh, it turns out that friction we are going to represent by this small f. Okay. Now, coming back, we also know that fluids, when I talk about air and liquid, they also flow. So the friction which they exert between their internal layers is called viscosity. Okay, this we'll talk about in properties of matter. Just for time being, if you talk about water and if you talk about honey, if you pour honey, then you will find that one layer moves over another very slowly. Okay, so that friction force in honey layers, internal layers, is more than the layers of water. Fine. So that is called viscosity. Now, it turns out that there are some fundamental rules which friction obeys. So that's what we are going to talk about it now. So friction force, first law of friction says that friction force between two surfaces is proportional to support force. Okay, we'll not use the word contact force, we'll talk about it later, or normal force. So friction force turns out to be proportional to contact force. Okay, uh, we are using R for it, so let us use R for it. So friction is proportional to this. It turns out that friction force, when you remove the proportionality sign, friction force comes out to be mu times R, and this mu is called coefficient of friction. Okay, so this is coefficient of friction. Now this coefficient of friction depends on nature of surface. Okay, so coefficient of friction depends on nature of the surface. If you say coefficient of friction is 0, then there will be no friction at all. Okay, so suppose if I talk about tire, there its coefficient of friction ranges between 0.6 to 1. Okay, so let us just take one number. For rubber tire, coefficient of friction is, let us just take a number, 0.8. Fine. So if friction coefficient is 0, then there will be no frictional force acting. Okay. The second point is that friction between two surfaces do not depend on apparent area of contact. So that means that suppose I have a block kept like this on a surface. Okay, let us draw it properly. Suppose I have a block kept over a surface like this. Fine. And you're going to apply force, then we, and let us say it slides. Fine. So we all know that friction will operate. So friction will act in this direction. Fine. Now it turns out that if you put the block like this, fine, the same block. So you can see the area here is a bit more, right? This much area of the block is in contact. Here this much block area will be in contact. So it turns out that when you apply, let us say, the force, okay, let us say you're applying it on its center of mass, okay, so that it doesn't topple, like it doesn't fall. Fine. It turns out that the same friction will operate here. So this friction force is independent of the area of contact. Okay, now let us try to understand the meaning of uh, this coefficient of friction and this. So as we told that friction we are going to represent, so static friction between two bodies, we are going to write it with like mu s n. Sorry, we are using R for normal force. Same way, kinetic friction between two surfaces, we are going to write it like this. Now, it turns out that this coefficient of static friction or coefficient of kinetic friction, they depend on the nature of the surface, and their values might change, okay, depending on the situation, what kind of surfaces are in contact with each other. Now, let us try to understand the meaning of this. Now, that means that suppose, okay, suppose mu s is, let us say, 0.5, okay, uh, and R is, let us say, 1 Newton. Okay, just so if I take this value, that means that friction, uh, static friction between the two surfaces will be 0.5 Newton. So this is fixed, but what I can do, I can increase this, right now. So like law 1 says that friction force is directly proportional to support force or normal force. So if I increase this, then I can increase friction, right? Let us take a simplest example. So let us say there is a block here and you are applying a force here, and uh, this block is not moving. So we all know that there will be friction in this direction, right? And how much will be that friction? Uh, there is a normal force R, and this will be mg. So if this block is at rest, right, then we know that friction will be equal to mu R, and R is nothing but mg, so friction will be mu mg, right? Fine. Now, suppose what we do now, suppose I apply now a force, let us say, in the same diagram, let us say I'm applying now force in this direction. Let us say that force is some uh, F1. So if I apply force in this direction, and let us say I'm applying force F here, and mg is in this direction, there is normal force acting in this direction, right? So what will be, and let us say the block is not moving still. Now what will be this friction force in this case? So you all can see, if you concentrate on this y-axis, you all can understand that in this case, since the body is not moving in any direction, it is obvious that this R will be equal to mg plus uh, F1, right now. So friction will be mu times R. Now R is mg plus F1. Now by applying a force in this direction, what we have done, we have increased the contact force, or we have increased the support force. So R was mg here, right now. R was mg here. But if I apply force in this direction, somehow R increases, so friction also increases. So by this way, we can say that if I increase the contact force, I can increase the friction force. Okay. Now, moving on. Now, it turns out that static friction is a self-adjusting force, okay, with an upper limit called limiting friction. Okay, so this, what we mean by that, the whole statement can be written like this, that the static friction is greater than 0 or less than equal to mu s r. Now what I mean by that, let us try to understand. Fine. So let us say mu s is zero point 0.5 Newton, sorry, zero point 0.5. It doesn't have a unit because it's a ratio of two forces. Fine. So suppose mu s is this, I have a 1 kg block here, mass 1 kg, and let us say I apply initially a force, let us say 1 Newton, fine, to move the block. Now we all can understand that uh, if I apply 1 Newton force, then what is going to happen? So let us find it out. So it says that if the block doesn't move, okay, static friction will act, right, in this direction. Now this static friction maximum value will be how much? So static friction maximum value will be mu s r. What is mu s? Mu s is 0.5, and r will be nothing but, this r will be nothing but mg, right? Huh? So what will be mg? G is 10. So R is mg. So I'm going to multiply this 10. So maximum value of static friction will be 5 Newton. Okay, this is the maximum value. Now this maximum value is called limiting friction. So let me repeat it once more. Static friction is a self-adjusting force with an upper limit called limiting friction. And the whole statement is written like this, that the friction can have value more than 0 and maximum value equal to mu s into r. So in this case, when I'm applying 1 Newton force uh, on this block, and let us say we are going to calculate whether it will move or not. So first we will find the maximum value of static friction, and it turns out 5 Newton. Now that means that when I apply 1 Newton force, okay, the friction will adjust its value to 1 Newton. Okay, now same way if I apply 2 Newton force, friction will adjust value up to 2 Newton. So this static friction, which operates when the surfaces are at rest, is a self-adjusting force. So if I go on, it can maximum go, if I apply now 5 Newton force, still it will not move because it can offer a maximum value of friction 5 Newton, right? Now, if I apply more than 5 Newton, okay, so let us say I'm applying 6 Newton force, then the body, then this value can't increase beyond this 5 Newton. Then the body will start sliding, okay, and when the body will start sliding, we talk about kinetic friction, okay. So this is very important that static friction is a self-adjusting force. You can try by yourself. If you take a body, let us say I have mobile in my hand. If I apply a very little force, it doesn't move. If I slowly increase the force, it will start moving for a particular value. Okay, so as I'm applying a little force, then friction is adjusting its value to that. If I'm increasing a bit more, it is increasing, but it can only increase to a point. Okay, after that, if I apply more force, the body will start sliding, and in that case kinetic friction comes into play. Fine. Now moving on, it has been proven that coefficient of static friction is more than coefficient of kinetic friction. This is experimentally proven fact. The reason being, when you put two bodies into contact, okay, so it may look to us that these two bodies are in contact, fine, but at the microscopic level, what happens, the surfaces, this is the block surface and this is the surface of the table, let us say, they somehow bond and they develop. So even it looks like that this entire area is in contact, which is not true. Okay, the real area in contact is very less. So what happens, these two surfaces will start developing bond, local bonds. You can say electromagnetic forces will start operating. So when these two surfaces are in contact and when you try to push it, then this bonds needs to be broken, right? Then only the body will start moving. And uh, this idea is also related with the fact that you need more force to start the motion than to maintain the motion. Fine. Now in the next video we'll talk about some questions uh, related with friction. Thank you.